Hello everyone. So today let's solve the problem 322 coin change, right? So let's see what the question states here. So we are given an integer array coins, right? So you can clearly see here integer array coins consisting of the integers, representing coins of different denominations. See, suppose if we are considering this one in the rupee, we have 1 rupee, 2 rupees, and the 5 rupees, right? So here, we are given an integer array coins representing coins of different denominations and an integer amount and an integer amount representing a total amount of money, right? So we need to return the fewest number of the coins that we need to make up that amount to make up to that particular amount, right? So see here, 1 to 5 we have, amount we have 11 here. So we can just go with a 5 plus 5 plus 1. So we need to return the, this word is very important, fewest number of coins. So we have to go with a minimal number of coins or the fewest number of coins that we need to make up that amount, that we need to make up that amount, right? So if that amount of money cannot be made by any combination of the coins, then we have to return -1, right? So if we cannot make up this particular amount with these coins, and in that case we have to return -1. So that's what they have given in the question, right? So let's come to the first example, man. Just give me a second here. Yeah, we have 1 to 5 and amount we have been given 11. So we can just go with 11 ones, right? So that also we can do, and we can just consider 5 twos and 1 1. That also we can do. So that is also one this thing. Or we have to go with the fewest this one, right? Fewest possible combination of coins basically, right? So this one we can just go with 2 5s along with the 1 1. So that this is the fewest basically, right? By looking at it itself we can say, right? So this one we have to go with, basically this one we have to go with, right? So this one 5 5 1, right? So we are making use of 2 5s and 1 1s. Total it will be 2 plus 1, which will lead to 3, which will lead to 3. So this 3 we need to return this one as output. See here, 3. Yeah, now we have coins we have been given 2 and the amount is 3. So this is impossible, man. 2 first we have to make, we'll be making use of the 2, then plus 2 plus 2 plus 2. So this will never be odd at all. So this will never be odd at all. Amount we have been given in the odd 3 basically. This is not possible. If it is not possible, we have to return -1. That's what they have given in the question. So here, see here, -1. So for the example 3, we have coin 1 and the amount we have been given 0. So we can just directly, so amount we haven't given at all. We have been given only 0. In that case, this is also one of the possible this thing, right? Cases, right? So this here, we just have to go with the 0. So this is one of the finest examples that they have included here, right? In the example 3. So yeah, now we have the idea. We have the idea. They have given us wonderful examples just for the sake of understanding now. Yeah. So before moving on with the approach, let me tell you one thing. So we will be making use of the dynamic programming to solve this particular problem, right? So 1DDP basically, right? So we'll be making use of the dynamic programming to solve this particular problem. Let's see the approach step by step, man, as I've said. So example, let's consider the same first example, this one. Let's consider the same first example for the approach, right? So coins we have been given denominations here 1 to 5, amount we have been given 11. So first we will be making use of the 1D DP array, DP of 0 to amount, where DP of X is nothing but the fewest coins to make some X, right? So first we will initialize, so this is the base case, DP of 0 to 0 and others to the large sentinel, nothing but the amount plus 1, right? So next part is iteration, right? Iteration, this is the idea we are speaking of basically. Next part is iteration. We'll iterate each coin, and for the sum from coin to amount, we will update the DP of sum that is equivalent to the min of DP of sum, comma DP of sum minus coin plus 1. Right? Let's try to implement the same thing for the example, the first example. Right? So just give me a second here. Yeah, first example, we are implementing the same thing for the first example, right? First, we have to start with the DP of 0 as we discussed the same thing here within the approach. Right, so now we'll be going with the DP of this one, and also we have to go with the DP of 0 to this one. All right, so here in this case, DP of 1 to level. So that is one of the things I have said. Right, so we can make use of 11 1 coins. Right, suppose if we are going with 1 rupees actually here, we can just go with a 1 rupee. We can just consider 1 rupee 11 times, right? That will reach to the amount 11. Uh, so this is using only once. Next, this is for the coin 1. So this is for the coin 1 we have considered. Next, we have to consider for the coin 2. 1, 2, 5 we have here, right? You can clearly see here 1, 2, 5. So for the coin 2, um, dp of 2 equals initially 1 and minimum of 2 from the coins, this one versus 1 using 1 2. So basically this will be dp of 3 equals to 2, 1 plus dp of 1 to dp of 11, nothing but 6. 6, again how, so 5 2 coins and this one 5 2 rupee coins and 1 rupee coin, right? So this will be in this way. dp of 2 equals 1, minimum of 2 from the coin 1 versus 1 using 1 2 basically. So this will be dp of 3 equals to 2, 1 plus dp of basically 1, right? To dp of 11 basically. This is equivalent to the 5 plus 1, nothing but the 6, right? So this is fine, easily understood. Now let's move on with the next step. We have to go with a 5 basically, right? So dp of 5 initially will be going with a 1 as usual, and dp of 6 we have here as 2. dp of 6 equivalent to 2. So this one will be dp of 6 equals 2. So 1 plus dp of 1 to dp of 11, that is equivalent to the 3. Here 5, 2 5 coins basically, 2 5 rupee coins and 1 rupee coin basically, right? So dp of 6 plus 1, so this will be equivalent to the 2 plus 1, 2 5 rupees coins and 1 rupee coin here in this case, right? So this will be here 2 plus 1, 2 plus 1, this is equivalent to the 3, right? So see here, the same thing they have given 5 plus 5 plus 1. So finally, so we will be going with the dp of 11 equivalent to 3, the last one that we got here, 5 plus 5 plus 1, 3, right? So the last one at the last cell, whatever we have got, that one we will be what returning as the output. So we will return 3 here. See, return 3, right? So if dp of amount remained here, let me delete this one. The output that we got here is dp of 11 is 3, right? So here if the dp of amount remained greater than amount, so if it is impossible case, this one second example they have shown, right? So if the dp of amount remained greater than amount, then in that case we will be returning -1. In our case we got basically 3, dp of 11 equals 3 in the last cell, so we will be returning the same thing in the form of output. So the output that we got here is 3, which is equivalent to the output that they have mentioned for the example 1 within the question, right? So our approach works absolutely correct. As we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. So what will be the time complexity here? The time complexity would lead to pico of 1 second. 1 second. Yeah, the time complexity would lead to pico of n into amount, right? So the time complexity would lead to pico of n into amount, right? So where n is nothing but the length of the coins, because for each coin we iterate sums up to the amount, right? So the overall time complexity would lead to pick of n into amount. Easy to understand. So what will be the space complexity? Space complexity is just big of amount basically. Why it is just big of amount here? So we'll be going with a 1D DP array, right? As I've said, so we'll be making use of the 1D DP. So we'll be going with a 1D DP array of size amount plus 1. So overall space complexity would lead to big of amount. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n into amount and big of amount respectively. Now, as we are completely familiar with the approach, let's do one thing. Let's quickly approach and the complexities. Let's start writing the code, right? So now, first, if the amount is 0, then no coins are needed. Third example they have given, right? That's one of the edge cases as well. So this one, if amount equals 0, then we have to return 0. Yeah, this is fine. Now, dp of x will hold the minimum number of coins to make the sum x, right? So this one we know. Also, let's make use of the amount plus 1 here as the sentinel value, meaning, so we'll be going with the impossible large here. So since we have to find with the minimal coins, right? As I've said earlier, we have discussed this one in the question. They have strictly uh, asked to find the or asked to go with a minimal amount of coins that we have to sum up to make up the amount basically, right? So basically let's go with the amount plus 1. So I'll just go with int sentinel equals amount plus 1. This is fine. The next one is, let's go with the dp array here. new int of, so this one will be amount plus 1. Yeah. Next step here would be, let's initialize the DP array. So when I say let's initialize the DP array, so let's go with here DP of 0 initially. It will be 0, right? So this is fine. Next, let's move on with the for loop man iteration part. So this one int I equals 1, I less than or equal to, we have to go with the amount. So this will be I plus plus. So within the for loop, what we will be doing here, so for each coin, we have to update the DP from the coin to amount, right? So this is nothing but the bottom up approach. We are going with a bottom up approach, right? So we are not going with the top down. We are going with a bottom up, right? So this is fine. So why we'll be doing, basically to ensure the combination using current coins are considered. Current particular coin, yeah, coins are considered basically. So again, one more for loop here. Or first, yeah, let's go with one more for loop here. This is fine. So this one, oh, 1 second, man. This one I completely missed it, I believe. So this one has to be iterated value of the DP. We have to set this one to sentinel. We are going with one more for loop. So this one will be for c equals 0. C less than, so we have to go with the length of the coins, right? So this is fine. C plus plus. So this is fine. Yep. Now within the for loop, what we'll be doing, let's go with the current coin denomination, right? So I'll just go with int coin equals this one, coins of C. Coins of C. For every reachable sum S that is greater than or equal to coin. So let's try taking this particular coin. Let's go with one more for loop. This one will be int S equals coin. So this one we can just write it on this way. S equals coin. S less than or equal to amount. So let me go with S plus plus, right? So this is fine. Now, if DP of S minus coin was reachable, then we have to consider using one more coin to form the DP of S. Then we have to take minimum with the existing value. So within the if condition. So let me write it on this way. If DP of S, so this one has to be, sorry, yeah, S minus coin actually. Yeah, this is fine. Plus 1 if it is less than dp of s, right? Uh, then I'll do one thing. dp of s equals dp of s minus coin. This is fine. Plus 1. Let me come out of this one entirely. Now, if DP of amount is still sentinel, nothing but when I say if it is still greater than the amount, then it is impossible for us to make up to the amount that they have mentioned, right? So then we have to display -1 in that case, right? So let's include that as well. So first, if the DP of amount, if it is greater than the amount, then we have to display -1. Else we have to display dp of amount. If it is possible, then we have to display dp of amount. This is it. Yeah. Now let me format the code once and let me hit the run button. I hope this works, man. This has to work. Let's see. Hmm. Amount. Yeah, this one. Sorry. This one greater than amount. First, we have to display -1 if it is true, right? Yeah. Let me run this one again. Where is this one? Line number 3. I have misspelled here. So the sample test cases are getting passed. So let me hit the submit button quickly, man. I hope this works for all the test cases. Yeah, you can clearly see here, man. All the test cases are getting passed. Means whatever the code that we have written works absolutely correct for all the test cases, right? So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.